Unit 2, Thermal Physics. It's all about heat. So this unit is not particularly large, and its question load in the exams. Oh, I forgot to move my mic closer. The question load of this unit is not very large either. So when it comes to multiple choice questions, you have about 3 to 4 in the entire exam. And when it comes to written questions, you maybe have one, maybe 1.5 questions in paper 4. So let's get started. This is the entire unit. It's not split into halves. So we're going to start with some of the basics. Again, as you understand, we have a checklist. No, انت ممكن تبص على checklist وتقول يا مستر, this is such a big checklist. يبقى الunit كبير. لا, it's just full of little definitions and descriptions, a lot of definitions and descriptions. And yes, of course, it shows up in paper 6. I'm talking about its load in the written papers. Paper 6 is a different paper entirely. يعني لوحدها خالص. We have our own revision for paper 6 بعد كده. It's just full of details. Details صغيرة قوي. To you, it's basic, but to the examiner, he needs to make sure you have these details. But I split this into 4 sections. Just the kinetic model. So what are solids, liquids, and gases, and melting and boiling and evaporation. Thermal expansion and gases. So what's expansion when you heat something? How do gases behave when they're heated? And their questions. Specific heat capacity on its own, because it's actually very important and relevant. We'll talk about specific heat capacity, how do we calculate stuff in it, and so on. And the transfer of thermal energy, which is conduction, convection, and radiation. It's full of descriptions, like full of little nitpicky details about what's the good conductor, what's a bad conductor, what are examples of them, and their questions. فيلا بينا, let's get started. Let's read the checklist really quick. Do I have water? Yes, because my throat's going to go out with this. Know the distinguishing properties of solids, liquids, gases. Know the terms for the changes in state between solids, liquids, and gases. Gas to solid and solid to gas transfers are not required. He's talking about melting, boiling, condensation, and freezing, but not sublimation and not deposition. So it's not chemistry. You know? Describe the particle structure of solids, liquids, and gases in terms of the arrangement, separation, and motion of the particles, and represent these states using simple particle diagrams. This is easy. Describe an increase in temperature of an object in terms of an increase in the average kinetic energies of all the particles. Indeed, that's the definition of temperature. Describe the relationship between the motion of particles and temperature. هي نفس الجملة اللي فاتت. It's kind of the same thing. بس adding فكرة بقى إيه? That the lowest possible temperature is -273, called absolute zero. And convert between Kelvin and Celsius عشان نعرف بس what's Kelvin, what's Celsius. Describe melting and boiling in terms of energy input without the change in temperature. Know the melting and boiling points of water. Describe condensation and solidification. Describe evaporation in terms of the escape of most energetic molecules. This is all stuff you need to read, like we agreed before. Maybe I should mismatch أول حصتين. And you just go through it like a checklist. هل أنت فهمت السنتنس دي ولا لأ? Because once you're done revising, you go back and reread these and you like tick on them. I was like, yeah, أنا فاهم دي, أنا فاهم دي. I don't know what this sentence means, which means I need to revise condensation, for example. Know that evaporation causes the cooling of a liquid. Describe the differences between boiling and evaporation. Describe how temperature, area, and air movement affect evaporation. Explain the cooling of an object in contact with an evaporating liquid. So let's start with the basics. What are the 3 states of matter? Solids, liquids, gases. Whenever we describe things in Unit 2, خدوا بالكم بقى, we have 2 perspectives that we need to keep in mind. An object from the outside has a certain volume, temperature, mass, and pressure. Okay. And shape, obviously. And on the inside, احنا assume that all substances are made of particles or molecules. They're all the same size, same shape, same everything. وكل الparticles أو المolecules دي, we can use the words interchangeably. Particles or molecules have 3 things. 1, they have movement or motion. So they have kinetic energy. There's a certain spacing or arrangement to the molecules. And there are attractive forces between them that affect all of these properties. فكل ما نيجي نجاوب على سؤال, every time we answer a question, هنجاوب عليه مرتين. Twice. مرة من بره مرة من جوه. So on the outside, fixed shape or volume واخبار temperature and mass or pressure ايه. And then on the inside بيحصل ايه المولكيولز. Do they move faster? Do they move slower? Do they move farther apart? Do they move closer to each other? Are the bonds very strong? Are the bonds very weak? كل ده هنقوله. بس that's what you need to keep in mind when you're answering questions في الunity. Solids have fixed shape and fixed volume. عارفين دي. We draw them by drawing, circles that are stuck together with very small spaces. They have very small spacing and regular arrangement. Keep this in mind. They vibrate about a fixed position, and they have very strong bonds. Liquids have a fixed volume, but no fixed shape. We draw them close to each other, but randomly. So they have small spacing برضو, just like solids. But they are randomly arranged. مفيش order ليهم. More like it's just random order. The way they move is that they slide over each other, so they don't vibrate, they slide. And finally, they have strong bonds. From very strong to strong. The weaker bonds اللي احنا قلناها دي, like that happened here, is what's responsible for all of this. And they don't have a shape, and the spacing increases, and the arrangement is random, that now they can move faster. That's all due to the slightly weaker bonds. Gases have no shape and no volume. All the molecules are super far apart. Just draw very few numbers if I ask you to draw molecules. And there's no arrangement, no order. How do they move? Very fast, very free, and randomly in all directions. What about their bonds? Very weak forces. This is just solids, liquids, gases, but the most important thing in Unit 2 is heat. When you heat something, you know that its temperature increases. فيعني إيه temperature? What's the definition of temperature? It's defined and known as the average kinetic energy of the molecules in a substance. Again, it's defined as the average kinetic energy of the molecules in a substance. يعني, if I have a substance that I'm heating, the molecules inside move faster. They vibrate faster, they slide faster, they move freely faster. And when you're cooling it, they move slower. Inside a substance, there's kinetic energy, little molecules, depending on their speed, and that affects its temperature. We measure temperature in degrees Celsius and a unit called Kelvin. هنشوف بنحول Kelvin ازاي. But ايه بقى الابسولوت زيرو دي? If temperature is a measure of the average kinetic energy, there is no maximum kinetic energy. ليه؟ نقدر نسخن as much as we want. Like we can give something as much energy as, the device that can possibly give energy can. Theoretically, there's a maximum, so مش هندخل فيها. But practically, there is a minimum. What's the minimum amount of energy inside anything? Zero. When something has zero energy, خلاص ما فيهاش, that's minimum. مفيش أقل من كده. The minimum amount of kinetic energy in a substance is zero. And when that happens, بنقول إن that's the lowest possible temperature at which the particles are and can have. يعني. ليه? Because this is at which the particles have no kinetic energy, or بنقول the least kinetic energy. Zero. يعني. But when you cool something to absolute zero, it has no kinetic energy. The molecules. يعني. What is that temperature? Negative 273 Celsius. تمام? You have to memorize that value. So what is absolute zero? It's the lowest possible temperature at which molecules have the least kinetic energy. What's the value? Negative 273 Celsius. What's Kelvin? Kelvin is another unit of temperature that actually uses absolute zero as its zero. Kelvin literally خد قال لنا, okay, my lowest temperature is zero. اسمها K. Celsius's temperature, the lowest thing, is negative 273 Celsius. فازاي بقى نحول from Celsius to Kelvin? You add 273. And how do you convert from Kelvin to Celsius? You minus 273. From Celsius to Kelvin, right? It's, let's say, for example, it's 50 degrees Celsius, for example. You add 273. تطلع كام? 323 degrees Kelvin. So just write K, but we degree. We don't draw the degree symbol. That's how to convert temperature from Celsius to Kelvin. طبعا and back هتعملوا minus. Next. We all know that if you heat a solid at a certain temperature, it will melt and change from a solid to a liquid. This is called the melting point. And if you boil a substance, as in heat a liquid up to the boiling point, it will change to a gas. This is called boiling. The melting point of ice is 0. The boiling point of water is 100. دي الأرقام الوحيدة اللي احنا هنحفظها. These are the only values to memorize. ماليش دعوة بأي substances تانية. But what I do know is in the temperature at which something melts is the same temperature at which it freezes. If the melting point of ice is 0, the freezing point of water is 0 برضه. And if the boiling point of water is 100 degrees Celsius, then the condensing point of steam is 100 degrees Celsius. ايه الفرق؟ الفرق في ان are you heating or cooling؟ لو انا بدي heat energy, it's melting and boiling. If I'm taking away heat energy, because أنا ما أقدرش أدي حاجة اسمها cold energy, it's either gaining or losing heat. So if the substance is losing heat because you're taking it away from it, it's called condensing or freezing. That's a very, very important thing to keep in mind. During, like if I have a substance and I heat it, when you heat something like a solid, the temperature بتزيد. Why? Because the molecules move faster. حلو. Kinetic energy of the molecules increases. But during melting, the temperature stays constant. It stays steady. It doesn't change. Why? Because the energy absorbed by the molecules during melting, it does not make the molecules move faster. لا. They have their maximum speed خلاص at that moment. Instead, the energy is used to weaken or break the bonds between the molecules. ليه? Because in order to change a solid to a liquid, I need the force to change. إن إحنا قلنا أهم حاجة هي الforce between the molecules. If the forces get weaker, the state changes. So from solid to liquid. And during boiling, the same thing happens. The molecules are already slightly farther apart, but they still have strong bonds. So what happens during boiling is that any heat energy you give it is used to completely break the bonds between the molecules. How? By moving the molecules very far apart. So you break their bonds. And that causes it to boil and change state. But since the temperature does not change, that means the kinetic energy does not change. طب, is it still gaining heat? Absolutely. Like, is it still gaining heat لو أنا بسخنها? Yes. It's just changing it or using it to break the bonds, مش to increase the kinetic energy. Okay? نفس الفكرة في الكوندنسيشن والفريزنج. Okay? نفس الفكرة في الكوندنسيشن والفريزنج. If something is condensing or freezing, it's losing heat. So it's cooling down. But the temperature doesn't decrease, it stays constant because the energy is used to pull the molecules closer to each other. Like that energy lost allows the molecules to move closer to each other and reform the bonds. فبتعمل bonds تاني and they get stronger, so on. So if I ask you, describe what happens during melting in terms of energy and molecules, هتقولي during melting the molecules gain heat energy. Oh, the answer is right here. The molecules gain heat energy to weaken. دي melting. The bonds between the molecules, there's an S missing, I'll fix that in my version. Between the bonds between the molecules and move them farther apart. But if I ask you, why does the temperature remain constant? Temperature remains constant because the molecules do not gain kinetic energy. العكس بقى طب in reverse. What happens during condensation or freezing? The molecules lose heat energy to strengthen the bonds between the molecules. How? By moving them closer to each other. Do the molecules lose kinetic energy? No, they don't. So the temperature stays constant. Okay? And that is the difference between melting and boiling, or boiling and condensation, melting and freezing. But a very important change in state, which is the the focus of a lot of questions is evaporation. What is it? Here's a cup of water, okay? If I decide to dump some of that water onto the floor, هيحصل إيه? And I leave it there for like an hour or two. Water disappears. Why? It evaporates. So what is it? Evaporation is when a liquid changes to a gas. إزاي? When the most energetic molecules on the surface of the liquid, they break their bonds and escape. Something you need to understand. Evaporation does not need heat to occur. تاني. Evaporation does not need heat to occur. بتحصل لوحدها. تقول لي ازاي يا مستر? Don't you need heat to break the bonds at the boiling point? Yes. Because the molecules already have energy. It just so happens that when molecules have the most energy and they reach the surface, they can use that energy to escape. It happens very slowly because there are conditions. اللي هي most energetic and on the surface. So it's very slow. But molecules can escape and evaporate. On their own, they don't need any energy. طب بقول لكم ايه بقى؟ If the most energetic molecules leave the liquid, what's left behind? مين اللي باقي؟ Less energetic molecules. And if less energetic molecules are left behind, the temperature will decrease. Temperature will decrease. So again, when the most energetic molecules escape, less energetic molecules are left behind. The average kinetic energy of the remaining liquid decreases. So the temperature of the remaining liquid decreases. Okay? Good. Now, one extra thing. If you have this liquid on an object, or as it evaporates and it cools down, it'll absorb heat from your body. And if I get some, sanitizer, if I get a sanitizer here, and I spray it on my hand, and I just leave it there, and just leave it there, what's going to happen to my hand eventually? And it's not a very long time, just a bit. It'll cool down. Why? Because as this liquid that's on my hand evaporates, it cools down. So it absorbs heat from the nearest object to it, which is me. So my hand starts to cool down. I'm going to dry this off بقى before I start feeling any colder. كده كفاية. Okay. How do you make something evaporate faster? 3 things. Heat it, because that means molecules have more energy. Increase the surface area. So the more molecules are on the surface, the more evaporation will occur, because molecules only evaporate when they're on the surface. And if there's air movement above the surface, يعني when I sprayed that alcohol in my hand, if I kept blowing some air on that liquid, that air pushes the air molecules that are on the surface and pushes them away. Now, this is as far as what the syllabus wants you to know. But you ask a really good question. Does humidity count? Humidity does affect evaporation. It's not part of the curriculum, but it's sometimes accepted in mark schemes, because the more humid the air is, the less evaporation will occur. Because the air is so saturated with water, there's no space for the water molecules to escape. خلاص يعني هيسكيبوا يروحوا فين? There's too much water in the air. But it's not an official part of the curriculum. It is physically correct. So I would rather we stick to بس the official things in our syllabus, because that's the limit of our questions. Even if he does accept it sometimes, but not every time. Okay. You're welcome. Liquid particles that are left behind gains energy, so evaporates even more till the whole liquid evaporates. Exactly ده اللي بيحصل لما temperature بتقل. So when the temperature of the liquid that remains decreases, it absorbs more heat, which allows it to evaporate faster. So it evaporates, so it cools down more, then it absorbs some heat, then it goes like, I can evaporate faster. And the cycle continues على ايدي لحد ما ايدي كلها تنشف. Differences between boiling and evaporation, because this is one of the first things we were asked to know. You're welcome. What are the differences? Boiling or evaporation? الاثنين liquid to gas. Both of them are from liquid to gas. ايه الفرق? Boiling happens at the boiling point, 100 Celsius. And evaporation happens at any temperature. It doesn't have to be the boiling point. طالما أقل من boiling point. يعني عند 100 we don't call it evaporation anymore. Less than 100 for water يعني. Less than 100 that's called a evaporation. What else? This one is stupid, but you see bubbles during boiling. You don't see bubbles during evaporation. Evaporation only happens on the surface. Boiling happens through the entire liquid. And during boiling, the temperature stays constant. But during evaporation, the temperature decreases. So both of these, all of these are differences you need to keep in mind. Now, to be frank, this first chapter, this introduction, is literally that introduction. There are key points that we use to build up the rest of the unit. You won't see a lot of questions directly about all of these topics in one go, just little parts of them, usually in multiple choice alongside like little parts of some questions. فتعالوا بقى في past papers. This is from June 23 on. Remember, I'm using questions from the most recent papers to demonstrate. I know there are questions in older papers, so I'm showing you how they're demonstrated in the most recent things. First, state the value of absolute zero. What is the value? Negative 273. Explain what is meant by the term absolute zero. Refer to particles in your answer. And it is the temperature at which particles in a substance have the least kinetic energy or no kinetic energy. All right? So that's when molecules have no kinetic energy. They stop moving, etc., etc. Now, before I continue, absolute zero is a new addition to the syllabus. فquestions من 2022 backwards مش هتلاقوا فيها كلمة absolute zero دي. It's only in 2023 عشان it's new to the curriculum. 4 students described the phrase absolute zero. Which student is correct? The lowest possible temperature. صح. Particles in a solid start vibrating. No. Particles do not have weight. That has nothing to do with absolute zero. Particles have the least gravitational potential energy. No, it's kinetic. The A is the correct answer. Yeah. Which statements about evaporation of water are correct? Evaporation causes the remaining liquid to cool. Yes. During evaporation, the more energetic particles escape from the surface. هي دي literally the definition بتاعت evaporation. Evaporation only happens at 100 degrees Celsius. لا. It happens at any temperature. So 1 and 2 are the correct answers. Finally, during a picnic on a warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Damp meaning wet. So if I have a bottle of lemonade, I prefer lemon mint, but yalla, it doesn't matter. And you wrap it in a cloth that is wet or damp. The water in that cloth will start to evaporate. And as the water evaporates, the temperature of the cloth decreases. فإيه اللي هيحصل للlemonade بقى? It will also cool down. Why? Because it will start losing heat to the cloth. فهو بيقول explain in terms of molecules. It doesn't matter if you use the word molecules or particles. يعني هنا بص L particles, هنا L molecules, it's the same thing. Explain in terms of molecules how evaporation cools the water in the cloth. هنقول له إيه? When the most energetic molecules of water in the cloth evaporate or escape, the remaining liquid temperature decreases. خلاص? They have less kinetic energy, which absorbs heat from the air. بس طبعا, do I need to mention that? لا, stop right here. He didn't ask for the lemonade. He asked for what? How the evaporation cools the water in the cloth. فده اللي هنقوله. The remaining liquid temperature decreases because the average kinetic energy of the remaining molecules decrease. ففي 3 حاجات قلتها هنا. I described evaporation quickly. Most energetic molecules escape. Then I described the temperature will decrease at the remaining temperature because the average kinetic energy of the remaining molecules decrease. So we talked about the ones who escaped, the ones who remained, and the temperature of the ones who remained. So obviously the cloth cools down. Okay, next. Let's talk about gases and thermal expansion. Yeah, checklist. Describe qualitatively thermal expansion of solids, which means there's no calculations, okay? And expansion does have calculations, but not in O-level physics, okay? Qualitatively, the thermal expansion of solids, liquids, and gases at a constant pressure. Describe some of the everyday applications and consequences of expansion, and explain the relative order of magnitudes of the expansion of solids, liquids, gases as the temperature rises. فالفرق ما بينهم والكلام ده والapplications. بعد كده describe the pressure and changes in pressure of a gas in terms of motion and particles and the collisions. Know that the random motion of microscopic particles in a suspension is evidence for the kinetic particle model of matter. اللي هي Brownian motion, huh? It's just evidence of the particle model of matter. Describe and explain this motion, called Brownian motion, in terms of random collisions between microscopic particles in a suspension. This word simply means liquid or gas, and the particles of the liquid or gas. Okay. Describe the pressure and changes in pressure of a gas in terms of the forces exerted by the particles colliding with the surfaces, creating a force per unit area. هنقول هنا momentum, okay? Know that microscopic particles may be moved by collisions with light, fast-moving molecules, and correctly use the terms atoms or molecules as distinct from microscopic particles. هنا بقى هيفرق هنقول molecules ولا particles. هنشوف بعد شوية دلوقتي. Describe qualitatively, in terms of particles, the effect on the pressure of a fixed mass of gas of temperature, change in temperature and volume, and change in volume and temperature at constant temperature. Meaning, عايزين نشوف ازاي temperature بيأثر على pressure وازاي الvolume بيأثر على pressure. Recall and use the equation PV equals constant أو P1V1 equals P2V2. We'll see that now. بس نبدأ الأول with a few basics. What is thermal expansion? When you heat something, the molecules move faster, so the molecules move farther apart, which makes the volume of the substance increase. دي اسمها thermal expansion. So increase in volume. ليه? Because the molecules move farther apart. فبص بقى, there's a difference between defining or describing and explaining. To explain اللي هي because the molecules move farther apart, faster and farther apart. But what is expansion? It's the increase in volume when the temperature increases. Keep that in mind. اليونت دي من اليونتس اللي فيها descriptions و explanations كتير. To describe and explain a lot. خلاص فبليز خدوا بالكم. What affects expansion? 3 حاجات. The state of matter. Gases expand more than liquids. Liquids expand more than solids. ليه? Because gases have very weak bonds, solids have very strong bonds. So the stronger the bonds, the less expansion will occur. Second, temperature. كل ما temperature يزيد, كل ما expansion يزيد, which makes sense. Because if you heat it more, it gains more energy, the molecules move even farther apart, so it changes space between the molecules increases more. The initial volume of the object. يعني amount of matter والinitial size بيفرق. ليه بقى? Because if you have like 2 molecules next to each other and you heat them, so they expand. But if you have 4 molecules next to each other and you heat them, so they expand. The amount of expansion you get عشان انتوا سخنت 4 molecules is more than the amount of expansion you get because you heated up only 2. But the bigger the object is, the more it will physically expand. It's like a percentage thing. If it expands 50% مثلا when heated, حاجة صغيرة هتكسباند شوية صغيرين، حاجة كبيرة هتكسباند كتير. عكس كلمة thermal expansion is contraction. So when the temperature decreases, the volume will decrease because the molecules move closer to each other. There are certain useful applications of expansion and certain problems caused by expansion. These are a few of the most common things that show up in questions. So thermometers. This is a useful application. How does it work? A liquid is inside the bulb. You heat the liquid because you put the bulb inside your mouth, for example. The liquid heats up and expands. فبيطلع لفوق ويديني temperature. Second, fitting rings over rods or wheels. قصدي إيه؟ لو أنا عندي ring, a ring, a circle, like something like my ring that I'm wearing here, and I want to put it on top of a rod or on top of a wheel, فوق عجلة كده. Now, if the ring is too small to fit, حاجة زي عشان أفهمكم, it's like the lid of a jar. Like if the lid of a jar is too tight to fit, it's not fitting well. So if I have a jar, and the lid اللي أنا عايز أحطه is too tight, it's not going to fit. بنعمل إيه؟ بنهيت الليد، بنهيت الرينج، بنهيت الحاجة اللي هتبقى على بره. When you heat it, it will expand. And when it expands, I'm exaggerating here, but when it expands and it gets bigger, it can now fit and cover the object. Now, when you heat the ring, it expands, and then you can put it on top of the object. Then you let it cool. فبتمسك في الobject, so it grasps onto it and doesn't let go. This is why if you have trouble opening a lid, a metal lid, one of the pieces of advice is to run it under hot water. Run just the lid, not the jar. Run the lid. حط الغطا بتاع البرطمان تحت المية السخنة. تلاقيه بيكسباند وطق، هتسمع صوت طقة كده, so you can now open it. Bimetallic strips. Why does water expand when it comes to ice? هنتكلم على دي في الآخر خالص. Bimetallic strips. What are bimetallic strips? These are strips of metal that are stuck together, two metals. It could be مثلا copper and iron. Could be any two different metals. المشكلة في إيه بقى؟ Because different metals expand at different amounts when heated, because they don't all expand the same way. If you heat them, والمثلا الكوبر عايز expand أكتر من الأيرون, this can't happen. يعني they can't, because they're stuck. They can't tear apart and split to expand. Instead, when they expand, the entire piece of metal curves. The hotter it gets, the more it bends or curves. لما بتبند وتcurve, الحتة on the outside of the curve is now longer than the inside. Geometrically speaking, the distance of the outer side of this curve is longer than the inner side of the curve. فلما بنسخن البايميتاليك strip ده بيبند, and the one on the outside expands more than the inside. طبعا if you cool it, the blue will contract more than the black metal, or copper more than the iron in this example. Okay. Next, what about thermal expansion's problems? There are three problems to keep in mind. Two of them are basically the same. Railway tracks can deform at very high temperatures. يعني لما بنسخنها. Same thing with bridges and roads. They can deform and break at very high temperatures. Basically, I mean, this could happen. If this is a railway track and the temperature gets very high because of the summer, the track could deform. It tries to expand and it can't, so it bends, it buckles. So we solve this by leaving gaps between different sections of the railway track. They're not huge, by the way. They're just like 2 or 3 centimeters at most. So they're very small, but they fix this problem. We allow the tracks to expand during the summer, and then during the winter they contract. ترجع تاني بقى during the winter. So why do we leave gaps between sections of a railway track or bridges? To stop them from deforming or buckling or breaking at very high temperatures. طب what about hanging electric cables بقى? The problem with hanging electric cables is that it's got two problems. Well, electric cables or telephone cables المتعلقة دي have to be hung just right. It can't be hung too stretched and it can't be hung too loose. علشان if it's too loose and the temperature gets hotter, it gets longer and it goes down. And it'll touch your cars, for example, if there are cars down here or people down here. So, you know, it besides them getting torn apart because people will hit them with their cars or like stuff. But yeah, it's very dangerous if the temperature gets too high. If the temperature gets too low, this metal will contract. It'll get shorter and shorter and shorter and it'll stretch, and then it'll be very taut or stretched. Eventually, because it's still trying to contract and it's very stretched already because it was short, هتتقطع. So this is bad. Too cold is very bad. Too hot is very bad. Okay. So keep these in mind. Very good. Now, I'll answer a question that's not really part of the syllabus, but it's really good info. Why does water expand when it becomes ice? Because water is unique. Did the people in the car survive or not? I don't know. Because water is very unique. Maybe. Usually when temperature decreases, we talked about contraction, صح? When temperature decreases, the molecules move closer to each other. صح? That's correct. So obviously when you freeze something, the molecules get even closer and they stick to each other. Water is the only material that when it starts to freeze, the molecules start to rearrange themselves in a crystalline order because they want to be transparent. المية لسه عايزة تفضل تبقى transparent. So it rearranges itself in a crystalline state. In order to create this order when it freezes, بتبقى solid. That's why ice is transparent برضو. It has to increase the space between the molecules compared to liquid water. And if the volume, if the space between the molecules increases, the volume will increase, فبت expand. This is only for water. This is like extracurricular and trivia, but this is only for water. Right? Does that answer the question? Yes, excellent. Yeah. I just remembered I forgot my morning meds. Now, Brownian motion. What's Brownian motion بقى? We're talking about gases بقى. Okay, talking about gases here. But before we do, can I repeat the applications of thermal expansion, the thermometer part? Thermometer is very simple. When you have a liquid inside a thermometer, it's mercury, and you put it in something hot, like your mouth, for example, because you want to measure your temperature. When the liquid heats up, it expands, and when it expands, it goes up and shows you what your temperature is. If your mouth is cold or the object is cold, the liquid will contract, والvolume هيقل, but the level goes down inside the tube. That's about expansion and contraction of a liquid inside the tube. Okay. So let's talk about gases. We'll start by talking about Brownian motion. What is this? This is and this is how we describe it, random and irregular, we can use the word jerky, motion of smoke particles in air or pollen grains in water, because there are two versions of this experiment. An experiment where we get a smoke cell, which is just a glass box with smoke inside. And we have another version where we get a Petri dish with water and pollen inside. Either way, when you look under a microscope and you look at both of these, you will find that the smoke particles, all right, move around random and jerky, random and irregular, like the directions don't change. Okay, good. Why? How do we explain this? So why and how do we explain this? It's because the each smoke particle is surrounded by little bits of air molecules. Every single air molecule, as it moves, eventually collides with this smoke particle in random directions, in different directions. So as the air, look at the way I'm using the terms, huh? Air molecules collide with smoke particles. So in this assumption, the word particle is larger and the word molecule is smaller. So air molecule or water molecule is smaller than the smoke particle, okay? فالاir molecules or smoke particles بتخبط, they collide with the smoke particle. Or it's water molecules colliding with pollen grains. Hey. But since we're talking about gases here, air molecules collide with the smoke particle, causing it to move random and jerky. So this is what you see, the motion. But this is what actually happens. Now, خدوا بالكم لو سمحتوا, when answering questions about Brownian motion, if you ever see one, it's very rare, if you see one, the order of what collides with what is important. Like it's the air molecules اللي بتcollide مع السموك particle. It's not the other way around. مش العكس اللي بيحصل. مش السموك اللي بيروح يخبط الاير هو اللي بيموف يخبط السموك. Please. Okay. Now, that بقى helps us talk about gas pressure. بما ان المولكيولز بتتحرك وبتخبط وبتعمل. So this helps us talk about the pressure of a gas. So what is gas pressure? What causes it? Please خدوا بالكم برضو هنا في descriptions كتير قوي. There's a difference between explaining how gases apply pressure and what changes the pressure. تمام؟ في فرق ما بين change و change و why there is pressure or how there is pressure. So how does a gas apply pressure? Now, imagine you have a gas molecule محطوطة في box والمولكيول دي بتتحرك. What does it do? بتcollide مع, it hits the walls of the box. Every time there's a collision, وبترجع تاني, like again, goes, hits, comes back. That collision الواحدة بس, يلا حلينا بقى momentum and we've seen the whole things that collide and rebound. That collision causes a change in momentum over time. صح? When a ball hits a surface and rebounds, that's a change in momentum over time. And that change in momentum is defined as a force. So gas molecules move freely, or particles, sorry, move freely, colliding with the walls of the container, experiencing a change in momentum over time. Change in momentum over time equals force. But this applies force, a lot of, because في الحقيقة بقى it's not one molecule, it's millions of them. This force collides or hits over the area of the walls. Force over area يعني ايه? Pressure. So force is change in momentum, and it's the collisions that cause the change in momentum. فتاني, if I ask you, it's always the same. If I ask you, describe how, explain how gas molecules or particles apply pressure on the container it's in, you will say gas molecules or particles move, or as they're moving, they collide with the walls of their container, experiencing a change in momentum over time, which applies force over the area of the walls, causing pressure. ممكن تخلصوا السنتنس causing a pressure. Okay? Good. طب what causes بقى the pressure to change? Obviously لازم حاجة في collisions تتغير. But there are two factors. One, temperature can affect pressure. Two, volume can affect pressure. And they're very simple. Temperature and pressure are directly proportional. يعني كل ما نزود temperature, pressure تزيد. Temperature and pressure of a gas are direct proportional. As long as the container is closed, يعني constant volume. يعني it's not allowed to expand. Think gas cylinder, think spray can بتاعت deodorant, for example. That's a closed container. So when you heat the gas in it, مش expand because the container stops it from expanding. The pressure بيزيد. Obviously, it explodes eventually. يعني. but maybe that's what you need. Okay. طب why بقى does that happen in terms of molecules? Because the molecules move faster, so they collide harder and more frequently. There are two things to say in terms of collisions. They collide harder and they collide more frequently. تمام؟ طب how does volume affect gas pressure? At constant temperature, مفيش heating, huh? How does volume affect gas pressure? Okay, so volume and pressure are inversely proportional. يعني كل ما الفوليوم يقل البريشر تزيد. So if you squish a balloon, for example, if you have a balloon and you squish it and you decrease its volume, eventually this balloon pops, which is proof that its pressure has increased, or at least the pressure of the gas inside the balloon has increased to cause it to pop. فده معناه ايه؟ لما الفوليوم تقل البريشر بيزيد. ليه؟ Because when the volume decreases, the space between the molecules decreases. They move closer to each other. So they collide not harder because the molecules aren't moving faster. They're just stuck in a smaller space, so they collide more frequently. If the space was large, they would collide less frequently عشان تاخد وقت أكتر عشان تتحرك from one wall to another. So when the space between the molecules decreases, they collide more frequently. ده اللي بيزود the pressure. So it's only one thing to say about the collisions. في temperature, it's two things to say. Now, between you and me, ده actually في equation بتربط لنا temperature pressure volume. equation دي بتقول PV equals nRT. يعني this is like advanced level physics شوية. بس احنا مش علينا equation دي بتاعت ideal gas. So we're only taking a portion of it, which is a PV. If we're going to see how the pressure affects volume or the volume affects pressure at a constant temperature, بنقول إن the pressure times volume is constant. أو بنقول P1 V1 equals P2 V2 اللي هو pressure times volume before your compression or your expansion equals the pressure times volume after the compression or expansion. Okay? Now, one of the last features هنا في checklist, if you remember, was recall and use the equation PV equal constant or P1 V1 equals P2 V2 for a fixed mass of gas at constant temperature, including a graphical representation of this relationship. Graphical representation يعني graph of P and V, pressure and volume. بس بما ان pressure والvolume are inversely proportional عكس بعض، ايه اللي هيحصل؟ كل ما الفوليوم يزيد البريشر هتقل. So it looks like this. This is the curve that we have in math. This is the curve that we have for what y equals 1 over x or x equals 1 over y. اللي هو inversely proportional. So this is the curve for pressure and volume being inversely proportional. It's a curve. Just memorize the shape because D, like, because some people think, I missed the volume increases, pressure decreases. It is not a straight line. Inversely proportional is not a straight line nasal. It's a curve nasal. Okay. طيب. Let's erase this. We don't need this. Yeah. Let's solve a few questions. This is from June 23. The temperature of fixed mass of gas, the temperature of a fixed mass of gas at a constant volume is decreased. يعني عمل إيه في temperature? Decreases. And the volume is constant. So it's a decrease in temperature. State and explain in terms of particles how the pressure of the gas changes. فيلا. You've decreased the temperature. فالpressure had إيه؟ Had decreased. So that's my answer to state. The pressure decreases. That's the answer to state. طب إيه explanation? You've cooled it down, صح? So the molecules are moving slower. So they're colliding with less force and less frequency. Right. So the speed of the molecules. أو ممكن نقول kinetic energy or the particles. هو بيقول particles, so I'll use it. Decreases. So they collide with less force and less frequently with the walls of the container. So, statement حصل لي السبيد حصل لي الكولlisions. You have to mention both of these, less force and less frequency, or less strongly and less frequently. That's fine. Now, part C بقى. Cylinder 1 contains 350 centimeter cubed of gas. Yes? Can you say less force instead of less force decrease in kinetic? No, you can't. Decrease in kinetic is instead of speed decreases. Force is force. You can say less strongly, like I said, or the collisions are weaker. That's okay. بس لازم في collisions, when you describe the collisions, تقولي 2 points في speed مع temperature, which is A. The force decreases and the frequency decreases. Okay? You have to say both. But the decrease in kinetic energy is instead of speed. That's fine. طب نرجع بقى تاني للC. Cylinder 1 contains 350 centimeter cubed of gas. That's volume 1. At a pressure of 9 times 10 power 4 Pascal. That's pressure 1. The gas is transferred to cylinder 2. And the pressure increases to 1.6 times 10 to the power of 5 Pascal. That's pressure A2. Calculate the volume of the cylinder. Which cylinder? Cylinder 2. Type. How do we solve this? How do we solve this? What's the rule? P1 V1 equals P2 V2. I know the syllabus says the rule is PV equals constant, but that's how I prefer to use it because it's much easier to remember PV equals constant than, sorry, P1 V1 equals P2 V2, then PV equal constant. It's less annoying, yeah. So P1 V1 equals P2 V2. Failed. What's the rule? Numbers, 9 times 10 to the power of 4 times 350 equals 1.6 times 10 to the power of 5 times P2 because I don't know, P2 because I don't know P2. صح? لا, I don't know V2. My bad. So we have P2, we need V2. Make it the subject. يلا, 9 times 10 to the power of 4 times 350 over 1.6 10 to the power of 5. Let's write that down. You end up with 196.875. Obviously, I'm going to round it up to 3 significant figures because I like that. So I'm on 197 centimeter cubed because that's the unit that we were using so far. Okay. Good. Very, very good. Next. State, this is an expansion question. State which state of matter, solids, liquids, or gases has the greatest thermal expansion. We know gas. State which has the least expansion, solid. Describe in terms of motion and arrangement. خدوا بالكوا. Questions which ask you to describe solids or liquids or gases are not very frequent, but when they do, be very careful who عايزكوا to describe ايه exactly. Movement, arrangement, spacing, bonds, like what does he want? So limit your answer only to what the examiner wants. Tell. Motion and arrangement, the structures of solids and gases. فهنقول ايه؟ يلا. Solids, molecules, particles, because he wants to use the term particles. I'll use that. Particles vibrate about a fixed position and have regular arrangement. Whereas هنا هنقول particles move freely and fast and have no arrangement. Before I continue, am I trying to explain why ولا am I just describing؟ هنرجع للكلام ده إن شاء الله لما نيجي نتكلم عن past papers بعد ما نخلص syllabus revision. بس the keywords which are command words are very important. I'm only describing, I haven't explained. Whereas فوق هنا, if you've noticed, احنا قلنا state and explain. Okay? State and explain. لا. No arrangement يعني برضو move random. لا. لا لا لا. Move motion or moving random حاجة, like he'll give us a mark for that. We no arrangement دي حاجة تانية. Like having no arrangement is another thing entirely. Okay? طيب. What are the 3 marks for? Ow, my ears. Sometimes the 3 marks خلاص بتبقى متقسمة عليهم وخلاص. Like again, this is something we'll go over إن شاء الله في past papers, okay? So focus on the marks في past papers أكتر when we start revising papers. But for now, the 3 marks in this question are for solids, like 2 points for solids, 1 point for gas that you need to correctly describe, أو 1 point for solid that's right and 2 points for gas that's correct. يعني هو مقسمهم كده. So he's expecting you to write more and he's looking for 2 correct things, like they vibrate in a solid or they move freely in a gas. They have regular arrangement هنا بس no arrangement هنا and so on. Okay? So he's looking for comparisons كده. So maybe درجة على ال vibration, درجة على ال motion, درجة على ال so on. So in this case, it's 1 mark for vibration, 1 mark for freely, and 1 mark إن أنت جبت سيرة إيه؟ ال arrangement هنا وهنا. Okay? Okay? Next. A student uses a microscope to observe pollen moving on the surface of water. Which statement describes the reason for this movement? Yeah. What's this? Microscope pollen يبقى دي إيه؟ Brownian motion. Well, the water molecules are moved by microscopic pollen particles. Huh? هو الwater is moved by pollen؟ لا. البولن هو اللي moved by water. The water molecules are moved by pollen molecules. ها؟ هل احنا بنستخدم كلمة molecules في الاتنين؟ ها؟ Remember that, huh? Remember that distinction بقى في ال Brownian motion بس when I said هنا it's a difference. في ال Brownian motion, where was it? Ah, yes. في ال Brownian motion I said there is a difference. Particles و molecules حاجات. Molecule is the small thing, so water or gas. And the particle is the smoke or the pollen grain. It's bigger. فارجع تاني للquestion. Microscopic pollen particles are moved by water molecules. صح. water اللي بيحرك البولن. Pollen molecules are moved by water molecules. برضه نفس الغلطة. So it's the order is correct. Pollen is moved by water. بس استخدم molecules و molecules. لا. Okay. Next. Give me a second. Let's talk about specific heat capacity. This is a very short thing because literally the entire point of this little thing is this formula, E equals mc delta T or delta theta. ايه بقى الفورمولا دي؟ This allows us to calculate the amount of heat energy needed to raise the temperature of a substance. أنا مثلا دلوقتي رحت اللي عملت لنفسي a warm drink عشان لما يبرد شوية أعرف أشربه so I can keep talking كده وأتكلم معاكم. بس here's the thing بقى. What did I do to make this warm drink? It's a very silly thing. What did I do? I boiled water الأول. Or technically speaking, I heated water up to the boiling point because it's not really boiling يعني. بس I heated water from room temperature, which is pretty cold here in Egypt. تعال نشوف temperature كام النهاردة. Oh, right now it's supposed to be 18. Obviously, the house is colder. I'm going to say 15. 16 ممكن. So let's say from 15 degrees to 100 degrees. Which means أنا عايز أسخن water by 85 degrees Celsius. How much heat energy do I need? معتمد على 3 حاجات. It depends on 3 things. One, it depends on the amount of water I'm heating. Am I heating 1 cup, or am I heating 2 cups, or am I heating 3 cups? So how many kilograms of water am I heating? 2, it depends on the change in temperature, obviously. خلاص. بسخن from 15 to 8 يعني to 100 مش زي ما سخن from 30 to 100 يعني لما الجو يبقى حر مش same different thing. And finally بقى, this is the important thing. It depends on the specific heat capacity of the substance. قبل ما نبدأ, however, let's define a very easy quantity called internal energy. In Unit 1, we defined this as thermal, لو فاكرين, and we said it's the total kinetic energy of the molecules in a substance, which makes sense, because لما بسخن حاجة, the molecules inside move faster. Keep in mind, temperature is the average kinetic energy of the molecules. يعني it's the speed of one molecule became, on average. I don't care how big or small the object is, just one molecule, how fast does it vibrate. Internal energy is all of the energy inside the substance. So the total of the kinetic energy of the molecules in the substance. طب ماشي. سخنت يا مستر الأوبجكت. خدت التوتال energy بتاعتها. You said it depends on the change in temperature. صح. And it depends on the mass. صح. And it depends on the specific heat capacity. AD exactly. Specific heat capacity represents the material that you're trying to heat. هل هي water? Is it water? Is it oil? Is it iron? Is it steel? What is it? اللي بتسخنه. Because iron, for example, like if I have an iron pan, a cast iron pan, or like an aluminum pan, بسخن بعمل بيها حاجة الصبح على الفطار or something, I'm cooking. The moment you put it on the fire, like if you wait for 10 seconds or so, هتلاقي البان ابتدى يسخن. It heats up very quickly. ماليش دعوة if it's a good conductor or not. I'm talking about how much heat energy did it need to heat up. تيجي بقى تحط water in that pan, it takes forever to heat. Why? Because water as a material, كmaterial, needs a lot of energy to heat up. مش سهل. It's very hard to heat. هي دي specific heat capacity. It's defined as the amount of energy needed, heat energy needed, to raise the temperature or change the temperature of 1 kilogram of a unit mass by 1 degree Celsius, by unit temperature. No, energy required per unit mass per unit temperature increase. So for example, the specific heat capacity of water, وانتوا مش هتحفظوا لي أرقام, you're not memorizing anything, okay? Is 4,200 joules per kilogram degree Celsius. معناها إن water needs 4,200 joules عشان تسخن 1 kilogram by 1 degree, يعني from 20 to 21 أو from 15 to 16 محتاجة 4,200 joules. Whereas iron, and my memory fails me, so Google to the rescue, please. Specific heat capacity of iron is 450. Only 400, I would say 450. It's 10 times smaller, 420 مثلا, joules per kilogram degree Celsius. If I have 1 kilogram of iron, عايز أسخنها from 15 to 16, هتاخد 10 times less energy. It represents the material, the substance. مش كل substances need the same amount of energy to heat up. Some materials have what we call a high specific heat capacity, تسخن بالراحة جدا, it takes a lot of energy. Some materials have a low specific heat capacity, تسخن بسرعة جدا, it needs a very little energy. But that also means إيه بقى? إن if it takes a lot of energy to heat up, it also takes a lot of energy and therefore time to cool down. كوباية النعناع اللي أنا عملتها دي, this hot peppermint drink اللي أنا عملتها دي, it took a while to heat up. أنا رحت وشغلت الكاتل, went to the toilet, came back, الكاتل لسه بيسخن المية. It took a long time to heat up. It's still hot. Why? Because it has a large capacity. It takes a long time to heat up. It also takes a long time to cool down. Whereas, here are a bunch of keys. Huh? If I take these keys and I put them in that hot liquid, for 15 seconds وطلعها هتلاقوها سخنة نار. But if I wait for another 15 seconds or 30 seconds in the air, it will cool back down. So it's not just about how much heat energy وخلاص. It affects how fast things heat up and how fast things cool down. How do you calculate specific heat capacity? The formula is C equals E over M delta T, where C is specific heat, delta E is energy, mass is M, and delta T is change in temperature. But the formula I like to always remember, because it's phonetically easier to remember, is E equals MC delta T. It's kind of like E equals MC squared بتاعت Einstein that most of you are familiar with. But it's MC delta T. Okay, فاحفظوا دي, and then rearrange if you want C or M or delta T. Energy equals mass times C times change in temperature. Done. Nice question يا علي. Why is it delta E, change in energy? Because دي ما بتحسبش the internal energy of the object. دي بتحسب change in energy اللي بديها للسبستنس. انت محتاج تدي للسبستنس energy قد ايه. بصوا حتى على الديفينيشن بتاعت specific heat. The energy needed to raise the temperature. هي مش التوتال energy اللي جوه الاوبجكت دلوقتي حالا. Because علي, if water is at 15 degrees Celsius, does it have energy inside it? Yes. صح, it does. يعني it has energy already. فلما تيجي تقول لي E equals MC delta T وتقول لي مستر دي سخنت from 15 to 100, انت ما حسبتليش التوتال energy اللي جواها. انت حسبت لي how much energy did you give it. انا اديتها let's say 10,000 joules to heat up from 15 to 100 degrees. تمام. Does it matter احنا نكتبها دلتا ولا لا؟ مش مهم. Like we don't have to write delta or change في الإي. بس it's there علشان نفهم الفيزيكس بيحاول يبقى very precise في الكلام بتاعه. Like the examiners want to be very precise. Okay. Next. Let's talk about the experiment needed to measure the specific heat capacity of a solid object or a liquid بقى. Because this is the last checklist point هنا. Describe experiments to measure the specific heat capacity of a solid or a liquid. So and the liquid. قصدي ايه بقى؟ If I want to measure the specific heat capacity, think of the equation first. C equals delta E over M delta T, which means I need to measure the energy, the mass, and two temperatures, temperature 1 and temperature 2, before and after heating. Mass is measured with the balance, easy. Temperature is measured with the thermometer, easy. How do we measure energy? You can't. We do not have a device that measures energy. احنا ما عندناش جهاز بيقيس energy كده حاف كده. فبنضطر نعمل ايه؟ نرجع ليونت 1 تاني. We go back to last time's revision بقى session ونقول صح يا مستر. If we have an electric heater سخان كده, like we get this block of metal مثلا iron هنا, وحطينا فيها الهيتر so we can heat it up, and a thermometer وقسنا الماس بالبالانس. Heaters أو any electrical device بيبقى مكتوب عليها رقم, something like 1000 W, 1000 watts, which is the power. But if I have the power بتاع الهيتر, I can easily say E equals PT, energy equal power times time. Power is already given. او زي ما هناخد في الالكتريستي ان شاء الله، وزي ما هنشوف in a question here يا هنا يا تحت somewhere، ان ممكن يديني، او لا we actually saw it last time, I'm sorry not here, last time، ان ممكن اديك voltage and current and ask you to find power. I can use voltage and current to find the power of the heater and then نحسب الانرجي. فانا محتاج power which is usually given or it's on the instrument, and we measure time using a stopwatch. We measure time using a stopwatch. Very nice. in order فكروا كده في الاكسبيرمنت realistically. يا مستر now انت عايز تجيب C, so I need to find power. لا دي given. time يبقى محتاج stopwatch. mass okay I'm gonna use a balance. change in temperature and measure the temperature before and after. ناخد الريدنجز نحطهم في equation, and that's literally the experiment, like it's not a big deal. So what is it? Measure the mass of the object using a balance. مش فارقة بقى liquid ولا solid, just measure the mass. طبعا remember, if you want to get the mass of a liquid, نجيب the mass of the empty container, mass of the container with the liquid, بعد نجيب the difference. Measure the initial temperature of the of the object. شغل الهيتر, measure the power, turn on the heater. Get the final temperature of the of the object, and measure the time taken to change the temperature. واحسب ال C. So it's all about just briefly describing how to measure every quantity in the equation. تعالوا بقى نحل. Let's solve these questions. June 23, paper 43. Define specific heat capacity. The amount of energy or heat or thermal energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius, or a unit mass by unit temperature. A student carries out an experiment to determine the specific heat capacity of a metal. A cylinder of the metal is heated by 12 watt, a 12 watt electric heater. But the power is given. State the readings. أنا مش هشرح experiment. I'm just going to tell him what do I measure. Power is not one of them because power is already given. C equals PT over M delta T. So what do I need to measure? Okay, T. So measure the time taken to heat the water. What else? Oh, sorry. أنا ليه بقول water هو الميتال. The metal. The mass of the metal cylinder. And the initial and final temperatures of the metal, or the change in temperature of the metal. خلاص? Energy is not a quantity that I measure. Energy بتتفك الباور وتايم, and I use these to find energy. This is often given or it's on the instrument itself, ودي بنستخدم stopwatch. But keep that in mind. Okay? Good. Nice questions. I love it when you guys chat كده وتقولوا لي what do you think, عشان افهم بتفكروا ازاي. يلا. This is bad June 23, 42, question 5. It starts off very tame. The dimensions of a room are 4.5, 6.1 by 2.4, length and width and height. The density of the air is 1.2. Show that the mass is 79 kilograms. He wants us to calculate the mass. I have density, I have volume, he wants mass. So if density is mass over volume, therefore mass is equal to density times volume. And density is 1.2. The volume is already basically given to me, 4.5 times 6.1 times 2.4. أسئلة الشو يا جماعة, like questions that ask you to show, you have to write the working down كده, like in sequence, in order. Some people are messy when they do the working, even if their answers are right. Try not to be messy with show questions. 79.06 or 0.56 kilograms. هو عايزنا نقول show that it reaches 79 فوصلت 79. We're going to use 79 or 79.1. نكملها. The power of the heater is 1100. So power is given. The specific capacity of the air is 1000. Remember, we have the mass up here. Oh, here. Calculate the time taken to increase the temperature from 16 to 20. يعني الدلتا تي كام قبل ما نبدأ 4 degrees Celsius. يلا. He wants time. يا مستر. Energy is power times time. Power times time is equal to mc delta t. Because remember, يا مستر, E equals mc delta t. You're absolutely right. What do I want? يعني في الأسئلة زي دي, keep in mind, what do I want? I want the time. The time is going to be the subject. The time equals mc over delta t. Over mc times delta t. Over power. Power هتروح هنا. We have the mass, which is 79.1, rounded up كده شوية, times the specific heat capacity, which is 1000. So it's given. Times delta T, which is 4, which we got here. Over P, which is given. أصعب حاجة في الفيزيكس يا جماعة, وده كلام بس كده عقبال ما أكتب على الكالكوليتر, مش usually ما بتبقاش المسألة نفسها. Some questions are legitimately hard. حاجة زي دي مش صعبة, هي حاجة زي بس دي you have to be focused so you can get the correct values وانتوا شغالين. Like substitute the values correctly, rearrange the formulas correctly, الحاجات دي. يعني it's 4 marks, بس ايه, بصوا على الworking. انا هقول MC delta t ونجيب التايم. وبعد كده actually محتاجين نروح نجيب الدلتا تي. خلاص. بعد كده actually هنستخدم الماس من فوق ونحطها تحت ونrearrange عشان نجيب التايم. So it's a few steps. 4 mark questions are actually very easy. هم بس فيها busy work كتير. طيب. Suggest one reason why the time calculated in AII is the minimum time needed to increase the temperature of the air from 16 to 20. لا بصوا أنا مش فاهم. So I need to like logically think about this. Because هقول لكم حاجة. One of the most common answers we use لما نيجي نتكلم عن specific heat capacity and why the answers are not correct هي عشان the heat is lost to the surroundings. But here's the thing. احنا بنحاول نسخن ال surroundings. This is a heater that's trying to heat a room. Why بقى? One reason why the time is the minimum time. You have multiple ways of thinking of this. في كذا طريقة تفكروا بيها هنا. One of which هي ان الروم بتلوز هيت للايه؟ outside the room. يعني ممكن تفكر فيها كده. The room is transferring or losing heat outside the room. ده لازم توضحه بقى كده. يعني through the windows, through the floor, through the walls, الكلام ده كله. Oh, guys, do we live in houses with just empty rooms لما بنحط دفاية؟ ولا do I have a couch and a cupboard and maybe a TV? So هل الهيتر هو احنا كمان في الأوضة is the heater only heating the air in the room وده اللي احنا حسبناه the air in the room is the heater only heating the air ولا what is it heating برضو it's heating the A the furniture and everything else. So you have two more things, two things that you can say here. Either you say some of the heat was transferred to the مثلا furniture in the room or objects in the room if you're not sure of that, or you want to avoid being like يعني you want to avoid making assumptions. So you say some of the heat was transferred outside the room through the walls, out the windows, أو أي حاجة تانية يعني. And just tell me how did it go outside the room. Now, you'll notice something before I start answering questions. Did I mention particles or molecules here? No, I didn't. Why? Because في كل الأسئلة اللي فاتت اللي احنا حليناها قبل كده, explain in terms of particles, describe in terms of particles. خلاص؟ هنا there is no mention of in terms of particles خالص. He doesn't want you to mention particles or molecules. فمش هنقولها. We're not going to mention particles. Okay? So I'm going to answer a few questions الأول. When writing down the answer to how many significant figures do we round it to? If you get really long numbers, my preference is always 3 significant figures. Mark schemes always write it to 2 significant figures, but that's for correctors and like people who are correcting the papers. ليها حركة. I mean, there's a thing, I'll talk about that later, inshallah. بس to stay safe, write it to 3. But mister, what if I write more than 3? You're welcome. Go ahead. Okay? Can we say the heat was absorbed by the furniture instead of transferred? Absolutely. You can say heat was transferred, absorbed by the furniture, lost to the furniture, taken by the furniture, like all of that works. لا, the particles don't take time to gain kinetic energy and transfer it to particle to a particle. خلاص, that's not why you need more time, okay? Because the time that we calculated is the time necessary for these particles to gain that energy at that power. The power is what determines the time. مش particles. The power is what determines the time. With specific heat capacity, obviously. يعني. So these two together give me the time. Why is this minimum, however? عشان في حاجات تانية بقى غير الاير. That's why. Okay. Let's talk about. Oh my gosh. I'm not going to read all of this, by the way. I'm going to go directly into this. بس هقول لكم بس what this is about. The last chapter is about transferring heat energy. So conduction, convection, radiation. So these are the details that you need to know about conduction or convection or radiation. So conduction, for example, I just want you to know the difference between good conductors and bad conductors, explain it in terms of atoms and free-moving electrons, metals and non-metals. Describe why gases and liquids are bad conductors, stuff like that. Convection is easier. You just want to know what is convection. So explaining convection in terms of density and experiments that show me convection. And explain how convection happens in liquids and gases. Like, why is it that convection is important for liquids and gases, but conduction isn't? Then radiation. Radiation is called infrared radiation or wave. It does not need a medium because it's an electromagnetic wave. The surface color affects radiation, right? And if an object is losing or gaining radiation, how does its temperature change? That's 4 and 5. Describe experiments to show me the difference between good and bad emitters of radiation. Experiments to show me the difference between good and bad absorbers of radiation. And how does the amount of radiation emitted depend on temperature and area? These are all details you're supposed to be familiar with once we finish describing all of these. The consequences of thermal energy transfer is very basic. Some of them will be woven into this stuff, for examples. Some of them I'll explain on my own. So explain some basic everyday examples and consequences of conduction, convection, radiation. So basically, I give you an object or a situation, explain how the heat is transferred, by which methods and why. And then complex applications, which means what if there is more than one transfer happening? And that's what I'll use in the very, 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 very end of this chapter. So I'm going to talk about a few common applications in questions. Okay. Let's start with conduction. Conduction is very basic. Conduction is the transfer of energy primarily through solids. But how does it happen? When you heat a solid, the molecules inside start to vibrate. And as they vibrate, they collide with and transfer energy to nearby atoms. So an atom vibrates, collides with the next atom. This atom collides with the next atom. This atom collides with the next atom. So it's a sequential thing. واحدة ورا الثانية ورا الثانية ورا الثانية ورا الثانية, so on. So it just keeps giving it one to the next to the next. سهل. But this is how conduction happens in non-metals. Conduction in metals happens due to two actions في نفس الوقت. Inside a metal, you have the atoms or molecular lattice. كلكم عارفين يعني ايه lattice, which is just a group of atoms or molecules together and they like vibrate together كده. They vibrate, they gain heat, they vibrate, and they give energy to each other. That's the boring, slow part. But metals also have free moving what? Electrons. بنسميهم free moving or delocalized electrons. They're also heated. بس بما إن electrons are free moving, they don't only collide with nearby atoms. They can also collide with far away atoms. يعني يخبطوا في الاتومز البعيدة مش بس الايه القريبة. Okay? Okay? So how does conduction happen in metals? Two actions happen. Atoms vibrate and collide with nearby atoms, and electrons move freely to transfer heat to distant atoms. Examples of good conductors are copper, iron, steel, aluminum. I know you know what metals are. I just kept a few examples in there for your sake. And examples of poor conductors are plastics, rubbers, wood, glass, cloth, wool, and such. Now, liquids and gases are also bad or poor conductors. Why? Because since conduction, now they don't have free moving electrons, but since conduction depends on how close the atoms are to each other, so that they vibrate and collide with each other, liquids can't because they're first farther away and second they slide over each other. Gases can't conduct or don't conduct well because the molecules are all far apart anyway. You cannot rely on ان انا اسخن molecules في حته and they go collide with molecules في حته تانية وترجع تاني. ما بيحصلش. Okay? Very good. Now, here's an experiment that demonstrates good and bad conductors. Again, very popular experiment. Here's what you do. Let's say you have a piece of metal and a piece of wood, two equally sized pieces of metal and wood. You stick a few ping pong balls or metal balls, I don't care, with wax, شمع. So you heat up some wax, it melts, you stick it, and it, dries up, or you get a hot glue gun, because that's what wax is, برضو, it's just wax. Hot glue gun, and you stick these balls to that piece of metal with that hot glue gun. لو أنا ابتديت أسخن, if I start to heat one end of that metal rod, metal is a really good conductor. هترانسفر الهيت بسرعة جدا, and as it travels through the metal هتسيح الواx, so the balls fall. طب if I do the same thing with wood, لزقت شوية ping pong balls على الwood, and I start heating this end, and before your imagination takes you far away, I'm not heating it to its combustion point, فمش هتولع, it's not going to catch on fire, all right? It's not going to catch on fire, it's not going to burn. I'm just saying, and you heat this end without burning. Maybe, just maybe, after some time, one ball will start to fall, maybe none. ليه? Because wood is a poor conductor. The heat barely goes through. So that's the difference between a good conductor and a bad conductor. The more balls or the more wax, and that's the important thing, the more wax it melts along the length of the rod, the better conductor it has proven itself to be. ده conductors. What about convection? What is convection? Remember, احنا قلنا liquids and gases are bad conductors. So they have to transfer heat some other way. They transfer heat by convection. And let us revise two things before I start talking about it. First, density is mass over volume. And second, if the temperature of a substance increases, the volume increases. اسمها thermal expansion. لو أنا دخلت الاتنين دول في بعض, if you heat something and the volume increases, but the mass doesn't change, the density will decrease. تاني, if you heat something and the volume increases, the density will decrease. هتبقى less dense. ولو بقت less dense, remember بقى, things that are less dense float in a liquid or even a gas. And things that are more dense sink in a liquid or even a gas. This is why, for example, if I fill a بالونة with air وسبتها هتسink, because the air is the same density as the air that's outside, but the plastic is slightly more dense. The rubber, I'm sorry, is more dense فبتسink. But you fill up a balloon with helium. Helium is less dense than surrounding air. For the density of the balloon is less dense فبتفloat. That's what temperature can also do. But again, how do you describe convection بقى? You heat a liquid and it expands. And when it expands, it becomes less dense. And when it's less dense, it rises. The cold liquid بقى that was here sinks instead, because ما ينفعش الهوت liquid يطلع ويسيب vacuum تحت فالcold liquid ينزل. طب eventually that gets hotter فيطلع والcold ينزل, and it gets hotter, and you end up with a convection current cycle where the liquid goes up and down. We call this a convection current. Okay? Does it end? Yes, it does. Very good question. Does it end? Yes, it does. لما الليكويد يوصل boiling point. Because when it's at the boiling point, هل في فرق في temperature? Is like the bottom hotter than the top or the top hotter than the bottom عشان يحصل flow? لا. All of it's at the same temperature. All of it's equally hot. مفيش convection current خلاص. What if it's a gas? Then there is no end. If it's a gas, then there is no end. The hot liquid will, hot gas, sorry, will forever rise, and the cold will forever sink. There is no end. Because realistically, اللي بيحصل إيه بقى? When that hot liquid rises, it starts losing heat to the surroundings بقى, اللي هي outside the room, or the atmosphere, outside into outer space. It cools down, and you end up with a cycle at a very large macro scale, السكيل بتاع الاتموسفير, it will never end. طيب خلاص كده؟ Now, keep in mind, لما بنحب نسقع حاجة, when we want to cool something, بنحط الاير كونديشنر او الايس فوق. Always cool from the top. ليه؟ ان in this room من غير ما اشغل هيتر او اير كونديشنر, الهواء اللي فوق دايما اسقع من اللي تحت. سوري, الهواء اللي فوق ادفى من اللي تحت. It's always warmer. The air up there is warmer. فلما احط الاير كونديشنر فوق, it cools the already warm air فبينزل, بيدي فرصة للcold air space انه ينزل. ودايما بنحط الهيتر, احسن مكان الهيتر فين؟ تحت. Because the cold air is already down here. فلما بيسخن cold air بيطلع ويعمل convection current. always heat from the bottom, always cool from the top. Next. Finally, but what is radiation? Radiation is the fact that any object, including yourselves and myself, emits an infrared wave known as an infrared wave. That's an electromagnetic wave. أنا كنت عايز أعمل بقى له ذاك. It's an electromagnetic wave known as an infrared wave. راحت دماغي ضربت infrared على طول. Radiation is just the fact that every object emits infrared waves. Infrared waves are just like light waves. They're electromagnetic, meaning they travel in straight lines, they can go through a vacuum, they go in all directions. بس بدل ما بيعملوا transferring light energy, they transfer heat energy. وطبعا لما الwaves دي تطلع وتخبط حاجة, that object absorbs it, الحاجة بتسخن. Done. So it's just a wave. ايه اللي بيأثر بقى على الwave دي? Two things. Surface area. كل ما الobject الsurface area بتاعته بتزيد بتطلع radiation أكتر. And this is important. Radiation is not emitted from inside the object. Radiation, infrared waves, is emitted from the surface of the object. Your body temperature could be very low on the inside, but your surface is hot, so you emit radiation. Your body temperature could be very hot on the inside, but if your surface temperature is low, مش هنemit radiation كويس، هنemit أقل. So if the surface temperature is low, you emit less radiation. If the surface temperature is high, you emit more radiation. ففي كام حاجة بتأثر على radiation؟ اتنين. الاريا كل ما زادت الراديشن زاد، والسيرفيس temperature كل ما زادت الراديشن زاد. بس في حاجة كمان بتأثر and that is color. And we split the colors into two types. Dull black، على فكرة دي actually حاجتين. Dull is the texture and black is the color. So it's like it's not shiny, it's not reflective. Dull black is the best emitter and absorber. أحسن حاجة. Whereas shiny white is the worst emitter and absorber. خلاص؟ Because black is not a reflector. This is an important bit بقى. The reason black is a good absorber and emitter of radiation, absorb يعني بياخد radiation, emit يعني بيطلع radiation, is because the surface ما بيعملش reflection خالص. if I'm wearing a black hoodie النهارده. If I go upstairs مثلا or outside in my balcony and I stand in the sun, my black hoodie is a very good absorber of radiation إنها مش بترفلect. But what if I get a white hoodie and I stand in the sun? That hoodie is a good reflector. I reflect the infrared waves. It's not going to let me absorb them. So white is the worst absorber and emitter of infrared waves. ليه? Because it's a good reflector. Okay? Yeah. You should be able to describe at least two experiments. One experiment for a good or bad emitter of radiation, and another experiment for a good or bad absorber of radiation. And these two are very basic experiments. يعني بصوا اللي بيحصل في أول واحدة. I get a metal box, it's empty on the inside, you fill it with hot water. So it's all equally hot. Every surface of this box has a different color. One's dull black, one's shiny black, one's dull white, one's shiny white. And you put a thermometer or a thermopile or an infrared sensor in front of every one of these. They will all receive radiation emitted by the surface of the box. مين أكتر واحد هيسخن؟ الدال black. This will heat up the fastest. مين أقل واحد هيسخن؟ الشايني white. هيسخن. It will heat up, but less than black. A lot less than black. Okay? What if you want to do an experiment to check the absorption بقى, not emission, like it's not a hot object that's emitting. What if you want to check the absorption of an object, of infrared radiation? Same thing. هنجيب 4 containers, metal containers, cans, boxes, we don't care. Paint them all different colors. حطوا heater في النص. And let it heat the boxes or the cans from a distance. يعني it's only radiation. مفيش conduction, مفيش convection. It's just radiation. أسرع واحدة هتسخن الدال black. It'll heat up the fastest. Because black is the best absorber. Shiny white will heat up, but the slowest. Okay? Yes. So that's the second experiment that you can keep in mind. I can change the shape of the boxes or the containers, but the concept still remains the same. Do objects only emit and absorb separately, or do they emit and absorb at the same time? طبعا at the same time. يعني when an object is hot, sure it emits radiation. بس لو جنبي حاجة تانية تديني radiation هاخدها. The rays are hitting me. But if an object is getting hotter, ده معناه ان it's gaining more radiation than it's losing. يعني بقى بتabsorb heat أكتر ما بتلوز. And if an object is getting colder, it's losing more radiation than it's gaining. And if an object is at a constant temperature, بتgain وبتlose energy at the same rate. نفس الامount. These are equal. So keep that in mind برضه. Finally, examples بقى that you might be familiar with or maybe you're not. فتعالى discuss a frying pan or a pot. I don't care. It's a metal pot with a plastic handle and you've got water inside. Step 1. ولعت النار. You turn on the fire. It heats the pan. How does it heat the pan? Conduction. But from the fire to the pan, that's conduction. Through the frying pan, يعني جوه الميتال بتاع البان, that's conduction. طيب, from the pan to the water, conduction. Because that's the part of the solid pan اللي لامسه الميه, that's touching the water. طيب, من الواتر لبقية الواتر, convection. Okay? From the water to the rest of the water, that's a convection. طيب, will the handle get hot if it's made of plastic? لا, because the plastic is a bad conductor or it's a good insulator. فبنخلي الهاندلز بتاعت البوتس والبانز دي ايه? plastic. Or an insulator يعني. Silicone, whatever it is. طب here's another very common example في questions بقى. Examiner really loves this بقى. If I go to مثلا if I مثلا make some hot chocolate at home and I want to take it with me to school. جبت a vacuum flask. A vacuum flask is just a tube كده, cylinder, معمولة من 2 layers. A bottle هنا اهو, which is actually carrying your hot liquid, inner bottle, and an outer bottle والspace اللي ما بينهم vacuum. So this space over here, actually there's nothing in there. It's not an insulating material, it's a vacuum. مفيش حاجة جوه. It's empty. ليه بقى? Well, الvacuum بيقلل الheat loss by a... What does a vacuum do? It reduces the heat lost by conduction and convection, because conduction and convection cannot happen in a vacuum. مين اللي ممكن يعدي? Radiation. That's fine. Because it doesn't matter if it's a vacuum or لا, radiation عادي, infrared radiation عادي. طب عشان minimize radiation, بنpaint السيرفس اللي جوه واللي بره silver. Because it's a good reflector or it's a bad emitter and absorber. But even if some radiation wanted to get out, it would reflect and stay in, في شوية بس بيخرجوا. So the reason we painted silver on the inside هو ده المهم. The inside layers دي كلها silver to keep the radiation in. And finally, a vacuum flask or travel mug عنده lid. What does a lid do? The lid stops 2 things. The lid stops evaporation. هي مش بتوقف البروسيس نفسها. It's just the vapor اللي هو بتاع الليكويد بتاع الهوت شوكليت اللي يطلع gets trapped. فما بيقدرش يطلع. So it reduces heat loss by evaporation and by convection. Convection of A. مش الليكويد جوه نفسه. The air that's above the liquid برضه عايز يعمل convection. When it gets hot, it wants to go up. So you trap that air. إن الفيبر ده فيه liquid evaporation والhot air بيحاول يطلع. والhot air بيحاول إيه؟ يطلع. And the lid stops them both. Finally, طبعا, the lid has to be made of plastic. Why? Because plastic is a good insulator. انتوا مش عايزين الليد نفسه يسخن ويconduct heat ويطلع على heat لبره. So these were examples of, complex heat energy transfers. يعني حاجة واحدة فيها كذا method of heat transfer, either being stopped or going through, and so on. تمام? Let's solve a couple of questions. This is from June 23. Figure 5.2 shows a cross-section of a double glazed window in a room. Like, I know my rooms, مثلا, I've made double glazed windows, meaning 2 layers of glass with air in the middle. State the main methods of thermal energy transfer from the room to outside which are reduced. Will this stop radiation? يعني هل ده هيوقف radiation؟ لا. This is our room. It's hot. So it stops. It does not stop radiation. Radiation يعدي. But conduction cannot occur because the air is a bad conductor. And convection cannot occur because the air that's trapped here, even when it gets hot, won't escape. يعني تعرفوا, if it was just one sheet of glass, sure الجلاس هيسخن، فالاير اللي بره لما يسخن هيعمل convection and it will escape. This hasn't happened because we've trapped it inside another sheet of glass. What have we reduced? Conduction and convection. بالظبط. Excellent. This is about from November 23, so very recent exam. A copper cooking pan contains water and it's placed on the hot place of a cooker. Oh, okay. Yeah. Yes, 1 mark for both, not for one. عشان else state the main methods. So you have to write both. Copper is a metal. The thermal energy is conducted through all solids by lattice vibration. Describe one other way in which thermal energy is conducted through the copper. احنا قلنا بقى بيحصل conduction through the vibration of lattice, vibrations and collisions, and free moving electrons. فهنقول literally كلمة electrons لوحدها درجة. Electrons move freely in copper. إن احنا نقول بقى free moving electrons دي درجة كمان. Transferring heat خلاص to distant atoms or lattices in the copper. فإن أنا بس أقول electrons وفري دي درجتين. And then I just say, hey, that they move inside the copper and they transfer the heat to all of the atoms or distant atoms. The outside surface of the pan is kept clean by regular polishing. بصوا بقى. The moment you see كلمة polish أو shiny أو dull أو black أو white, know that this question is about radiation. على طول. Question ده عن radiation. To explain one advantage of keeping the surface of the pan shiny. هو shiny surfaces are poor أو bad emitters of infrared radiation. صح؟ طب how is it an advantage besides being clean يعني? Because a shiny surface is a bad emitter. It will lose less heat to the surroundings. فوانا بسخن أكل أو مية في الكوبر كان دي أو البان دي, it's not going to lose as much heat to the surroundings. فبتقلل الهيت loss by radiation. Shiny surfaces are bad emitters of infrared radiation, so they lose less heat to the surroundings by radiation. Oh, my fingers are freezing, so I'm getting very clumsy with my typing. Thermal energy passes into the water through the base of the pan. بتعدي through the base of the pan, huh? What we talked about here. بتعدي through the base of the pan. Identify the main method by which thermal energy is transferred بقى. بصوا على language. Throughout the water. مش from the pan to the water, through the water itself. اسمها ايه the method that transfers through the water? Convection. Do we also say they're good reflectors? لا, you don't. Not in this case. Reflectors mention reflection if you're talking about absorbing from the surroundings, okay? يعني لو هي object is cold and it wants to absorb heat from the surroundings, you can say it's a good reflector if you want. That's fine. Okay? Finally بقى, because احنا ما شفناش سؤال convection هنا قوي يعني we reduce this is a good conduction and radiation question. بص بقى, this is a mixture بقى of things. This is from June 22, paper 4. On a sunny day, the sun warms the road. Describe how energy from the sun reaches the earth and warms the road. I mean, what? ايه اللي بيقوله ده? How does energy come from the sun? By what? By what? By radiation, صح؟ Oops. By radiation. بس مستر 3 درجات يبقى أكيد لازم أقول إيه؟ اسم الراديشن نفسه. What's the radiation called? Infrared radiation. So, or infrared waves, that's fine. All right? So, infrared. So, حلو. So, the sun emits infrared radiation. That's great. حلو جدا. Then what? And it travels through the vacuum. And it hits the road and it's absorbed by the road. شكرا. مستر يعني مديني كل سبيس ده just عشان اقول radiation واسمها infrared and it can travel through a vacuum? Yes. So infrared radiation is emitted by the sun, travels through the vacuum or a vacuum, and is oops, and is absorbed by the road. Good question. Do you mention anything about the color of the road? هل تجيبوا سيرة الcolor? He did not mention color, صح؟ فأنا مش هجيب سيرة color. He will mention color هنا. He will mention color بعد شوية. The examiner will mention color. So yeah, هتفرق بعدين. The temperature of the road بصوا على language بقى. The temperature of the road is greater than the temperature of the sea. طب ما السي بيabsorb ال sunlight والroad بيabsorb ال sunlight بس the road is hotter. Why? وراح قال لي جملة كده في النص في الهوا كده for some reason. The surface of the road is black. Suggest one reason. اقترح يا ترى ليه يا ترى يا ترى. Why is the road hotter? Because the black color is a good or the best or a better absorber of is a good absorber of infrared radiation. Yes, and only because the black is a good absorber. The air above the road is heated by the road. Describe how this affects the molecules of the air. طب molecules of the air هيعملوا ايه? This is just a basic thing. The air is heated. هيحصل ايه? The molecules. When anything is heated, the molecules move faster and farther apart. علشان لما بنسخن أي حاجة, the kinetic energy of the molecules increases. You could say that instead of faster. And the substance expands. ده طبيعي جدا. Okay? It's just, بص على language again. How does this affect the molecules of the air? ما سألش how is it transferred? What happens to the air? Does it rise? Does it fall? لا لا. He just said what happens to the molecules when it's warmer or when it's heated. Finally بقى. A cyclist traveling along a road notices that a cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. You may include a diagram if it helps your answer. تعال اشرح له. هنا. You are here. This is you. On your bike. مش مهم البايك. When you're on the road, you feel a cool breeze coming. يا ترى ليه؟ Because if the road heats the air around you, the air around you starts going up. So the hot air, which is now less dense, rises. So the cold air, which is cooler at the sea, moves towards you كده. عشان يعمل convection current بقى. عشان يحصل convection current. So you end up with a convection current كده. طبعا انا مش راضي ارسمها من فوق because you've got the entire atmosphere. ماشي؟ بس it's just this way. فكل اللي هنقوله ايه بقى؟ The hot, or مش هنقول the hot air. The air above the road rises because it's less dense. So you've got cool air from the sea coming in to replace it. You don't have to draw. هنقول ايه بقى؟ The hot air above the road rises درجة because it is, or it's because its density decreases. Language accent شوية درجة. So cool air from the sea replaces it or comes in to replace it. فبيدخل cold air مكانها. If you really want to include a diagram, that's if you want to, you would say something like this. يعني بصوا, you don't need anything. هتقولوا road, هتقولوا hot road, خلاص وتقولوا C وترسم لي hot air rises cool air بس ده كل اللي انا محتاجه. اوكي. So, this was one of the very rare questions, like a 9-mark question, which was completely about heat transfer من أوله لآخره كده. Like, mentioned infrared radiation and radiation and convection in an application. Now, this is a good question, and I'll end it with this. In these types of questions, do they give marks if we miss a point but you drew? Yes, but depending on your diagram. All right, let's say, for example, you forgot to mention that the hot air rises. I mean, let's say you drew this, but you have to describe, okay? So you said something like the air, there is hot air above the road, or the density of the air above the road decreases and is replaced by the cold air from the sea. You forgot to mention the air rises, بس انتي في الدايجرام you drew the air going up. تاخدي الدرجة دي مكان دي. خلاص؟ Because you supplemented your answer with a drawing. Because you forgot the word it rises, خلاص خدتيها. Okay? Nice. Or maybe you remembered to say that the air above the road is hot, so it becomes less dense and it rises, but you forgot to mention cool air جاي from the sea. But you drew it. فتاخدي درجتي. These are the only 2 marks that you can replace. يعني يا إما كده يا إما كده. Yes. Very good. And with that, we're done with Unit 2.